Morning, geometry class. 4 days left. Well, after today anyway. Peppa and Rebecca were so excited they were jumping all over. I had to get them out of the way, you guys. Anyways, Father, bless this class, please, and help to go very well, and that this would make sense to everybody. In Jesus' name, amen. Okay, so we're going to look at circles still, and we're going to look at arcs and stuff, and this may look crazy right now, but I think that once I do it, hopefully it'll be easy for you. You might want to read pages 756 through 759 before you hit pause in the video and just read through that a little bit before you go into this. That's up to you. Okay, the first kind of problem they're going to give you is a circle graph with percentages in it, and they want to know the measure of AB. So all you have to do is take your percentage, like from A to B. If you look in here, the percent they put in there is 12%. They have to give that to you. And then you just multiply it by 360 because that's how many degrees are in a circle. So 0.12 times 360 gives you 43.2 degrees. That would be what this arc out here is equal to. To be truthful, that's how big this angle in here is too. The central angle, this is called a central angle because the center is the vertex of the angle. This angle and this arc always have the same measure. Arcs are measured in degrees just like angles are. Okay, so A to C to D is a major arc, so we go from A to C all the way over to D. So what we need to do is add the 12, the 18, and the 20 together. And if you add those three together, you get 0.50 or 50%. Times that by 360, that would be 180 degrees. So from A all the way over to D would be 180 degrees, and that makes sense. And here's another major arc, CDA. So I'm going from C to D, pass through D all the way over to A. So I have to add the 20, the 20, and the 30 together, which gives me 70% times 360, which is 252 degrees. So again, I think that those are pretty straightforward and simple for you guys. All right, here they're doing a little something different. They're giving us a couple central angles. They're giving this one's 20 and this one's 90, but then that's all that they're giving to us. And so before I answer these three questions that they're asking me about, I am going to go ahead and fill in everything I know and then come back and answer these. I think it's easier that way. Well, this angle and this angle, those are vertical angles. So if this is 20 degrees, then this one here has to be 20 degrees. Since this is a box here, I know that this is 90 degrees. And I know that this is half a circle here, so it has to add up to 180. So 90 and 20 is 110. That's going to force this one to be 70 degrees. This is 20 out of the 180, and so this one over here would be 160 degrees. And so now that I've got all the angles in, now remember that whatever the central angle is, so central angle is 90, that means this arc B to C is also 90. The arcs and the central angles match every single time. It's just a simple concept. Okay, so arc AB, all I have to do is write the central angle for A to B, which is 20 degrees. Measure of D to C, that's D to C, was 70. I figured that out, so I'm going to write 70 degrees. Major arc ECA, so I'm going to go from E to C to A. Go in the direction of whatever the letters go. So E to C to A, I'm going to have to add all these together, so that's going to give me 180 plus 20. That would be 200 degrees. All major arcs are over 180 degrees. 180 degrees is a semicircle. Anything bigger than a semicircle is considered to be a major arc. Minor arcs are smaller than 180. Okay, so let's go to the next one, which is this one up here. Well, what they did was they told us that this angle is equal to this angle here, which means that this arc out here is equal to this arc. Also means that this segment right here, because these are congruent triangles, is that this segment right here is equal to this segment here. So what I can do is I can write an equation. Since I know those two segments are equal, I can write that 4x minus 12 is equal to 2x plus 10. Okay, I'm going to go ahead and solve that. I'm going to subtract 2x from both sides. I'm going to add 12 to both sides. And divide by 2, I get x equals 11. They wanted to know the distance from B to D. So I'm going to take that 11 and plug it in here. 4 times 11 is 44. 44 take away 12 is 32. And so 32 is the answer for the distance from B to D. And if you plugged it in for C to D, 2 times 11 is 22 plus 10 is 32. Okay, so Charlie is very excited. Here we go. This one is, they have to give you that, just up there, they have to give you the circle B and circle E are congruent. You name a circle by the letter that's in the middle, and you just put a little circle with a dot. It looks kind of like somebody's eyeball or something, I don't know. But these two circles are equal, that has to be true. AC is congruent to DF, so they're telling you this arc is equal to this arc, which means, since the arcs are equal, that these angles in here are equal to each other. And so when I go to do the work on this, I'm going to say, well, okay, then 2x plus 30 has to equal 3x minus 15. So again, I'm going to do the math, subtract 2x from both sides, add 15 to both sides, I get x equals 45. So I'm going to take the 45 and I'm going to plug it in. They want to know D to E to F. So 2 times 45 is 90 plus 30 is 120 degrees. Okay, now if you plug this in up here, you would get 120 degrees. Again, that's a check for you to see if you had it right. And it does give you 120. Okay, this is the last type of problem. And in this problem, there's a theorem that states that if you have the radius goes through perpendicular through the chord AB, this chord could be anywhere right here, but the deal is, if that's true, that this distance and this distance from A to C and from C to B are exactly the same. And so their question would be something like, hey, how far is it from A to B for this chord if we know these two measurements? Well, the easiest way to do that is to say to yourself, okay, this is 8. We're going to make ourselves a right triangle. And this hypotenuse here, see you have that right triangle right there. We'll put a little right angle in there. This hypotenuse is the radius of the circle. But from here to here is also the radius. And we know that 8 plus 3 is 11. So we know this is 11. So we've gotten two sides of a right triangle. So what we're going to do is use a squared plus b squared equals c squared. And you always use this for this type of problem. Okay, so my a to me would be 8. So 8 squared would be 64 plus, I don't know the b. C squared would be 11 squared, which would be 121. So now I'm going to subtract 64 from both sides. And we get b squared equals 64, which is 3657. So we take the square root. I didn't do this ahead of time, so I'm going to estimate it. It would probably be around 7.6. You guys can check me on that. So b is 7.6, and they want to know how far it is from A to B. I'm going to double this. So I'm going to add 7.6 to it again, and that would give me 12, 1, 15.2. And so the answer right here would be 15.2. So when you see this type of problem, always use Pythagorean theorem. Okay, so you might have to watch that more than once, but those are the type of problems you're going to get today. I want you to, let's see here, page 760, 1 through 18. 1, 2, and 3 are just general questions. You might have to go back and read this a little bit, and the answers will be right there. And then they give you problems similar to what I've done up here to help you out. So remember, the main thing is that the central angle, if it's 30 degrees, it equals the one out here. Same thing here. If this is 70, then the arc CD is 70 degrees. Arcs are measured by their central angles. Oh, happy a great Monday. 4 days left. That's very exciting.